Hi everyone, I hope your studying is going well. As you prepare for your SL Paper 1 tomorrow morning, I'd like to give you an answer key for last year's Paper 1. The first question is statistics. We want to find out the median mark from an ogive. So basically you just look on the y-axis and you take your halfway point. So half of 100 is 50. You go across until you hit your graph, and then you go down to the x-axis, and we can read that that is 52, 54, 56. So the median is 56. To find the interquartile range, that's the range from Q1 to Q3. So that's 75% of the way to 25%. So we want to find out how far is it from 75% of the way to 25% of the way. And this just happens to be 75 and 25 because the total is 100. So 25 is exactly 40. And 75 is exactly 70. So the interquartile range is Q3 minus Q1. So 70 minus 40. So the range is 30. And this is measured in marks. Functions question. We want to find the inverse of f. So f of x just means y equals 2x minus 1. To find the inverse, you change the x and the y coordinates, and you solve for y. I'm going to leave y on this side, maybe move the 1 over to the other side by adding 1 on each side, and divide both sides by 2, and you get y equals x plus 1 over 2. So that's the inverse function. F inverse of x is x plus 1 over 2. Now for part B, we want to find the composition function, f of g of 1. This terminology just means f of g of 1. So the first thing we want to find out is what happens when you plug the number 1 in for x in g's function. So that means that instead of x, I put the number 1 in g's function. And that gets me 3 times 1 plus 2 is 5. So now I'm going to put the number 5 into f's function. So instead of x, I'm going to put 5. 2 times 5 minus 1 is 9. Question 3 is a trigonometry problem. So I'm given the maximum and the minimum points, and I want to find the value of the amplitude. Now the amplitude is just how high above the middle line is your graph, or how low below the middle line. So I need to find out where the middle is. The middle is going to be halfway between the y-coordinate of the maximum and the y-coordinate of the minimum. So halfway between 2 and negative 4. So let's see, what's halfway between that? That would be 2 plus negative 4 divided by 2. So negative 1. That's 3 points below 2 and 3 points above negative 4. Okay, so the amplitude is how much it takes to get from the middle to the top or the middle to the bottom. So the amplitude would be from negative 4 to 1 is a value of 3. Show that the period is pi. So the period is how much the distance it is from one peak to another peak. There's the period. Okay, so if I'm going from a maximum to a minimum, that would be half the period. So I can just take the x-coordinate for the minimum, 3 pi over 4, minus the x-coordinate for the minimum, pi over 4, and I get 2 pi over 4, which is pi over 2. So that's half the period. So now if I just take that number times 2, then I'll get the whole period. So to find the value of b, I just need to remember the equation that b is 2 pi over p. So b is 2 pi divided by the period of pi, so b is 2. Now, c is some number between 0 and pi. So in order to find c, it's the hardest one out of the transformation problem. So when you have a transformation of a cosine or a sine, a is the amplitude, vertical stretch. B is the horizontal stretch. C is a horizontal translation. And D is a vertical translation. Now let's check and see if I need to use sine or cosine. Cosine. Okay, so for a cosine graph, I need to know what the basic cosine looks like. The basic cos starts at a maximum and ends at a maximum. So it starts at the maximum point. So if the maximum point is not on the y-axis, then in order to find c, I just need to know how far did that maximum point move. That horizontal translation is my c value. So I just take a look at my graph and see how far did my c value, how far is my maximum away from my y-axis. And that value is the x-coordinate of the maximum, pi over 4. Probability problem. To find the value of r, let's see, what am I given? I know that the probability of getting a 3 is 20%. And the probability of getting more than 1 is 50%. I know that the total of all the probabilities has to be 100%. So it has to add up to 1. So if, let's see, bigger than 1 means not equal to 1. So that means 2 or 3. Bigger than 1 is 50%. So that means that r and 0.2 is 50% of the total, so r is 0.3. Now, given the expected value, find the values of p and q. So the expected value is calculated by just taking x times the probability of x. 1 times q. 2 times r. 3 times 0.2. Adding up all those should give you the expected value. So just multiply the top and the bottom and add up all the terms. Okay, so that means that q plus 2r plus 0.6 is going to be equal to expected value, which they told me is 1.4. So q plus 2r is equal to 0.8. And since I know that r is 0.3, q plus 0.6 is 0.8. So q must be 0.2. So this one's 0.2. This one is 0.3. So altogether I've got 5. So p must also be 0.3. And then I get 100%. Because I need all of my values to add up to 1. 0 and 1 are 50% of the values. Transformation question. F of negative x means that I change all the x coordinates from positive to negative. It's a reflection over the y-axis. So I'm going to take that negative 2 and make it positive. 0 stays the same. Because I'm going to take this whole shape from the original one and just flip it across the y-axis. Goes up 2 spots, and over like this. And it stops there. The graph of f is transformed in order to obtain g. What transformations did they do in order to get g? Well, let me take a look at this original function again. So f is my original. Make sure that you don't use part A to get to this part. Got to start again from the very beginning. So I'm starting from this one that I draw in black. And I want to know, how can I get to the one underneath it? So I know that I need to do expansions first and then translations, because expanding is multiplying, translating is adding. So I do my BEDMAS, my multiplication, division before addition and subtraction. So how much do I need to expand by? It looks like this graph became 2 times taller, because instead of going up 1, it goes up 2. The slope of this part has slope 2, like that. So I would say that my expansion value, which is my a value, is going to be 2. Expands 2 times vertically. My b value is how much it moves left or right. So let's see. It looks like I moved it 1 spot over to the right. Now remember, to get something to move right, I need to have minus. I need to have x minus 1 in order to get it to move 1 unit to the right. So what that means is that my b is going to be negative 1 in order to get it to move right 1. And finally, I flip it upside down over the x-axis. In order to do that, I need my a value to be negative. So a negative a gives it a reflection. So a is negative 2, b is negative 1. The quadratic. In order to get 2 equal real roots, what I need is for the determinant to be equal to 0. Now the determinant is a part of the quadratic formula that's under the square root. So that's this part here. That's called determinant. So what I want is for b squared minus 4ac to be equal to 0. Because then when I take the square root, I get no answers. So I don't have any positive or minus. And my one single root would end up being this part right here. Otherwise, I'm going to get 2 possible answers. So when I plug in b as k minus 1, a is 1 and c is 1. I want that to equal 0. So don't forget that when you have a bracket squared like this, that actually means you're writing out the bracket twice. So you get k squared minus 2k plus 1 minus 4 equals 0. You got to expand these terms into the brackets. And then we get k squared minus 2k minus 3 is 0. So now we'll factor it to get k minus 3, k plus 1 equals 0. So there's 2 answers for k. Now I might just want to check that really quick. So x squared plus 2x plus 1 equals 0. So that's when k is 3. Does it actually have 2 equal roots? Yay, it does. Okay, when k is negative 1, then I would get x squared minus 2x plus 1. Does that actually have 2 equal roots? Yay, it does. Oh, killer question. Question 7 is always a killer. So this is kind of like binomial theorem with a twist. So I'm given that 1 plus 2 over 3 to the power 2 over 3x to the power of some number times 3 plus nx to the power of 2 is equal to 9 plus 84x and so on and so forth. Can I find the value of n? Well, first of all, I don't even know how to expand the first bracket because I don't know what the power is. Normally I would use binomial theorem, but I'm kind of stuck. But I do know how to expand something that's squared. What that means is that I just take the bracket times itself. So that gives me 9 plus 6nx plus n squared x squared. And if I multiply that by this thing, then I should get 9 plus 84x. Oh boy. How can I expand with a power of n? Well, I need the binomial theorem, which says that in order to expand that, to find the terms, the first term would be n choose 0. 1 would happen n times. 2/3 would happen the rest of the time, 0 times. Next term would be n choose 1. 1 happens n minus 1 times, and 2/3 x happens once. N choose 2. 1 would happen n minus 2 times. 2/3 x would happen twice, and so on and so forth. And all of this will get multiplied by 9 plus 6nx plus n squared x squared. Whew. And all that has to be equal to 9 plus 84x, and so on and so forth. Okay. Well, luckily, this first term here is just the number 1. 1 to the power of anything is 1. Anything to the power of 0 is 1. N choose 0 is always 1. So here I have 1. Actually, 1 to the n minus 1 is still just the number 1. So the second term still has a 1 in it as well. I almost don't have to write that part. I can just put 2/3 x to the power of 1. Okay, so I'm simplifying a little bit here. I didn't even write that third term, and I'll show you why in just a second. Okay, so how can I get the term 9? Well, the first term comes from multiplying the first part of the first bracket and the first part of the second bracket. 1 times 9 is 9. So that term works. Now how can I get the term 84x? Well, that's going to happen anytime that I put something that already has an x together with a constant, or in this bracket something that's constant together with an x term. So if I multiply those two terms together, 1 times 6nx and n choose 1, 2/3 x to the power of 1, times 9, that should give me my 84x. If I solve this, I can find out what n is. So the first part is 6nx. N choose 1. Any number choose 1 is just n. There's n ways to choose one thing out of a group. 2/3 x, 9 equals 84x. And suddenly this looks solvable. Now, of course, if this is a real exam, don't mind me as I grab my power cord. If this is a real exam, you would skip question 7 until the very end. Okay, you'd only come back and do this if you had enough time. 9 divided by 3 is 3. 3 times 2 is 6. This is also 6nx. So I get 12nx is equal to 84x's. X's cancel. 84 divided by 12 is 7. So n is 7. Whew. You could also do this by trial and error. Just make a table for n is 1, n is 2. It wouldn't take you too long to get down to 7. Quite often binomials can be solved using trial and error. A good way to check your work if you have extra time. Okay, so don't forget that half of the marks of your test come from question 8, 9, 10. So don't get stuck up on question 7 and miss 8, 9, 10. In order to solve question 8, vector problem, we need to show that PQ is this. PQ is just Q minus P. So 0, 4, 1 minus negative 1, 6, negative 1, or 0 minus negative 1 is 1, 4 minus 6 is negative 2, and 1 minus negative 1 is 2. Done. Now how can we write an equation for L in terms of the form R equals A plus TB? Well, A is kind of acts like the y-intercept. That's any point on your graph. So we can choose the point P, or we can choose the point Q. T is going to be a variable, and B is acting like the slope. And so is PQ. It's kind of like the slope from P to Q. So we just put the value for PQ in there, and there's our equation of a line in the form R equals A plus TB. Another answer would have Q as your initial condition. Now you're given a second line. So this is L1, this is L2. We want to find the cosine of the angle between PQ and L2. So that's where we're going to use that cosine formula, which is the cosine of an angle is the dot product divided by the magnitudes. I shouldn't really be calling this L2. I'm trying to think of another name to call it. Really what I want to use is the slope of L2. The slope of L2 is this part right here. Maybe I can call it AB. So to take the dot product of two vectors, I want to take my slope of L1, which was 1, negative 2, 2, and my slope of L2, which is 3, 0, negative 4. I'm going to dot those together and then find their magnitudes for the denominator. Multiply the two magnitudes. Okay, so dot product is just multiplying the tops, multiplying the middles, multiplying the bottoms, and adding all those results together. Where the magnitude is finding the length. So that's just using the Pythagorean theorem. X squared plus y squared plus z squared, or 3d. So just finding the lengths of those vectors. 3 squared plus 0 squared plus negative 4 squared. Okay, so 1 times 3 is 3. This one cancels. 2 times negative 4 is negative 8. And let's see, 1 plus 4 is 9. And 9 plus 16 is 25. Well, these are nice numbers. So on the bottom, we get 3 times 5, which is 15. And notice, they didn't even ask us to find out what the angle is itself. They're just asking us to find out what's the cosine of the angle. So I can stop there. I don't actually have to find the angle. Now these two lines intersect at point R. Find the coordinates of R. So that's just saying when is this second line, 4, 2, negative 1 plus s, 3, 0, negative 4, when is that equal to the first line? Negative 1, 6, negative 1 plus t 1, negative 2, 2. Any one of those two things equal. So we can solve for s and t. So basically what this does is it makes three different equations. It makes equation 4 plus 3s is negative 1 plus t. That's the first line. Or 2 plus 0s is equal to 6 minus 2t. This is probably the easiest one to solve here, right in the middle. If I move the t to the other side, I would get 2t equals 6 minus 2. So 2t is 4. So t is 2. And then I could do it by trial and error. Or I could plug that 2 back into here. And I would get 4 plus 3s is equal to 1. So 3s is equal to negative 3. So s is negative 1. And then I could check it. So 4 minus 3 is equal to 2 minus 1. Yay! 2 is equal to 6 minus 4. Negative 1 plus 4 is 3. 1, negative 1 plus 4 is 3. It works. So these two lines intersect when s is negative 1 or when t is 2. And when t is 2. So now let's find out what point that is. So in order to find out what the point is, we need to find out what r is. So we're just going to take one of the two lines, doesn't matter which one. We'll plug in whatever value we found for t and s. So I'm using the second line, and then we'll just calculate the point. So we'll go negative 1 plus 2 times 1. 6 plus 2 times negative 2. Negative 1 plus 2 times 2. And just calculate those numbers. So negative 1 plus 2 is 1. Negative 4 plus 6 is 2. And 4 minus 1 is 3. Oh, cool. 1, 2, 3. And we can also check if it works the same for this line. So 4 minus 3 is 1. 2 plus 0 is 2. Negative 1 plus 4 is 3. Yay, it works. Probability question. Question 9. So we've got two bags. Bag A has 3 white balls and 4 red balls. 2 balls are chosen at random without replacement. So this tree represents, first branch represents the first ball. So what's the chance that you get a white ball? Well, there's 3 balls, 3 white balls out of 7 total, so 3 out of 7. What's the chance you get a red ball? 4 red balls. And if you take one out, there's a 4 in 7 chance. Now, the second branch of the tree represents getting the second ball. So in this first case, it's saying, okay, we already got a white ball out of the box. So now what's the chance that we got another white ball? Well, now there's only 6 balls left, so the chance that we get another white ball would be 2 out of 6. What's the chance that we get a red ball? Well, there's 6 balls left, and out of those 6 balls, there's 4 red balls that we could get. So there's a 4 out of 6 chance. And the bottom part of the tree says, okay, we already got a red ball out. After getting out a red ball, what's the chance of getting a white ball? Well, there's 3 white balls out of 6 possible, so 3 out of 6. The chance of getting red balls is the same. There's 3 red balls in there, so 3 out of 6 chance of getting a red ball. Find the probability that 2 white balls are chosen. So that means that we get white on the first time and white on the second time. Whenever you use the word and in probability, that means you're multiplying. So we got 3 out of 7 times 2 out of 6. So 6 out of 42, aka 1 out of 7 chance. Okay, bag B contains 4 white balls and 3 red balls. So here's another bag, 4 white balls, 3 red balls. When 2 balls are chosen at random without replacement from B, the probability that they're both white is 2 out of 7. The standard die is rolled. If a 1 or a 2 is obtained, 2 balls are chosen without replacement from bag E. Otherwise, they're chosen from bag B. Find the probability that the 2 balls are white. So that's going to be, what's the chance that you get a white from A? So you're looking for 2 whites from A or 2 whites from B. So that's the probability that you get 2 whites from A and the chance that you get 2 whites from B. So you're not going to have both happening at the same time. So what's the chance that you choose from A in the first place? The chance that you choose from A is 2 out of 6, because you would choose from A if you got a 1 or a 2 on a dice. What's the chance that both those balls will be white? Well, we had to figure out that in part 2. It's a 1 out of 7 chance. What's the chance that you would choose from B? Well, we would choose from B if we got 3, 4, 5, or 6. So that would be 4 out of 6 chance. And the chance that we get 2 balls from B, 2 white balls, is given to us. It's 2 out of 7. So the total probability is 2 out of 42 plus 8 out of 42, or 10 out of 42, aka 5 out of 21. Now, conditional probability. Given that both balls are white, find out the chance that they were chosen from bag A. So that's saying, find out the probability that you get 2 whites from A, given that you got 2 whites. So that's the probability that you get 2 whites from A and you got 2 whites, divided by the chance that you get 2 whites. Well, if you get 2 whites from A, they're definitely going to be 2 whites. So 2 whites from A and 2 whites is just 2 whites from A. Okay, so the chance that you get 2 whites from A is this probability here. 2 out of 6 chance that you choose from A, 1 out of 7 chance that those are both white. The probability that you get 2 whites is what we just calculated. 5 out of 21. So this is a total of 2 out of 42 over 5 out of 21, which is 2 out of 42 times 21 over 5. Or divide both of them by 21, you get 1 out of 5 chance. And the last question, number 10. Logs! Yay! Okay, so you're given a point on the graph. You're given a function. This graph is y equals log base something of x plus 3. And because we know the point, we know that this is x and y. So we can actually plug those numbers into the equation and find out what p is. So we're given that 2 is log base p of 6 plus 3. So 2 is log base p of 9. Now remember, in order to take a log to the other side, you can take its base and make it the base of an exponent on the other side of the equation. So that's the same as saying p squared is equal to 9. There's two possibilities. P is 3 or P is -3. But we know that the base of a logarithm cannot be negative, so cross that one out and we get 3. Now it says we have a reflection in the line y equals x, which is the definition of an inverse. If you reflect in the line y equals x. So the y-intercept of graph G is going to be the same as the x-intercept of graph F, because they're inverses of each other. The x's and the y's change. So I just look and see what the x-intercept of graph F is, and that's going to be the y-intercept of graph G. So in order to sketch a graph, all I need to do is change all the x's and y's. So instead of having the point 62, I'm going to have the point 26. Instead of crossing at -2, I'm going to cross the y-axis at -2. Instead of having a y-asymptote, vertical asymptote, I'm going to have a horizontal asymptote at -3. So my inverse, my reflection, looks like this. So reflection about the line y equals x, which makes it a mirror image, an inverse function. To find g of x, I just have to change x and y. So instead of having y equals log base 3 of x plus 3, I'm going to change my x's and y's. I'll have x equals log base 3 of y plus 3. I just have to solve for y. So to do that, I take my log base 3 and I put it on the other side of the equation as a base of the exponent. And then I move the 3 to the other side, and I get y is 3 to the power of x minus 3. Done.